Hello friends, welcome back. We are studying Advanced Java Programming. In this current lecture, lecture number 30, we are going to study unit number 4, that is networking basics. In the current lecture, we are studying syllabus and networking basics point. Unit number 4, it is a networking basic, have 6 hours, marks 10. And these are the some syllabus points. First point, socket overview, client server, reserved sockets, proxy servers, internet addressing. Second point, Java and the net, the networking classes and interfaces. Next, inet address class and its factory methods, instance methods. Fourth point, TCP/IP client sockets, in this whois protocol. Fifth point, URL, format of the URL and the URL class. Sixth point, URL connection class, TCP/IP server sockets, example. Seventh point, datagrams, datagram packet, datagram server and client. These some points we are going to study in this networking basics, which has the 6 hours and 10 marks. First, networking basics, unit 4. As we all know, Java is practically a synonym for internet programming, or Java is called as the internet programming language. For this, there are number of reasons, not the least of which is its ability to generate secure cross-platform portable code. However, one of the most important reasons that Java is the premier language for network programming are the classes defined in the .NET package, Java.NET package. This package is responsible for providing the classes, interfaces, all the things for networking support. They provide an easy to use means by which programmers of all skill levels can access network resources. We are exploring the Java.NET package in this chapter. It is important to emphasize that networking is a very large and at times complicated topic. So, we are focusing on several of its core classes and interfaces. First point, networking basics. Before we begin, it will be useful to review some key networking concepts and terms that we already know. At the core of Java's networking support is the concept of a socket. A socket identifies an endpoint in a network. The socket paradigm was part of the 4.2 BSD Berkeley Unix release in the early 1980s. Because of this, the term Berkeley socket is also used. Sockets are at the foundation of modern networking because a socket allows a single computer to serve many different clients at once, as well as to serve many different types of information. This is accomplished through the use of a port, which is a numbered socket on a particular machine. A server process is set to listen to a port until a client connects to it. Numbered socket is called as the port. A server process is said to listen to a port until a client connects to it. A server is allowed to accept multiple clients connected to the same port number, although each session is unique. To manage multiple client connections, a server process must be multi-threaded or some other means of multiplexing the simultaneous input output. Socket communication takes place via a protocol. Internet protocol. First protocol, Internet protocol, is a low level routing protocol that breaks data into small packets and sends them to an address across a network, which does not guarantee to deliver said packets to the destination. Next is the Transmission Control Protocol. TCP is a higher level protocol that manages to robustly string together these packets, sorting and retransmitting them as necessary to reliable transmit of data. The third protocol, User Datagram Protocol (UDP), sits next to TCP and can be used directly to support fast, connectionless, unreliable transport of packets. IP, TCP, UDP, like these protocols we are using for the socket communication. Once a connection has been established, a higher level protocol ensues, which is dependent on which port we are using. TCP/IP reserves the lower 1024 ports for specific protocols. Many of these will seem familiar to us if we have spent any time surfing in the internet. Port number 21 is for FTP, 23 is for Telnet, 25 is for email, 43 is for Whois, 79 is for finger, 80 is for HTTP, 119 is for net news. Like this, port numbers are reserved for specific protocols, and the list goes on. It is up to each protocol to determine how a client should interact with the port. For example, HTTP is the protocol that web browsers and servers use to transfer hypertext pages and images. It is a quite simple protocol for a basic page browsing web server. Here is how it works. When a client requests a file from an HTTP server, an action known as a hit, it simply sends the name of the file in a special format to a predefined port and reads back the contents of the file. The server also responds with a status code to tell the client whether or not the request can be fulfilled and why. A key component of the internet is the address. Every computer on the internet has one. An internet address is a number that uniquely identifies each computer on the net. Originally, all internet addresses consisted of 32-bit values organized as 4 8-bit values. This address type was specified by IPv4 or Internet Protocol version 4. However, a new addressing scheme called IPv6 Internet Protocol version 6 has come into play. IPv6 uses a 128-bit value to represent an address organized into 8 16-bit chunks. Although there are several reasons for and advantages to IPv6, the main one is that it supports a much larger address space than does IP version 4. To provide backward compatibility with IPv4, the low order 32 bits of an IPv6 address can contain a valid IPv4 address. Thus, IPv4 is upwardly compatible with IPv6. Fortunately, when using Java, we won't normally need to worry about whether IPv4 or IPv6 addresses are used, because Java handles the details for us. It is IPv4 or IPv6 or combination, these can be handled by the Java directly. Just as the numbers of an IP address describe a network hierarchy, IP address numbers describe a network hierarchy. The name of an internet address, called its domain name, describes a machine's location in a namespace. For example, www.osborne.com is the com domain reserved for US commercial sites, and it is called Osborne after the company name, and www identifies the server for web requests. An internet domain name is mapped to an IP address by the domain naming service. This enables users to work with domain names, but the internet operates on IP addresses. This is the basics of networking: address, IP addresses, TCP, IP, UDP, IP protocols. The networking classes and interfaces. Java supports networking classes and interfaces. Java supports TCP/IP both by extending the already established Stream IO interface introduced in chapter 19 and by adding the features required to build IO objects across the internet. Java supports both the TCP and UDP protocol families. TCP is used for reliable stream-based IO across the network. UDP supports a simpler, hence faster, point-to-point datagram-oriented model. The classes contained in the java.net package are shown here. These are the java.net package classes. First class is the authenticator. These are the examples of classes: authenticator, cache request, cache response, content handler, cookie handler, cookie manager, datagram packet, datagram socket implementation, HTTP cookie, HTTP URL connection, IDN, INET 4 address, INET 6 address, INET address, INET socket address, interface address, jar URL connection, multicast socket, net permission, network interface, password authentication, proxy, proxy selector, response cache, secure cache response, server socket, socket address, socket IMPL, that is implementation, socket permission, URI, URL, URL class loader, URL connection, URL decoder, URL encoder, URL stream handlers. Like this, vast amount of classes are provided in the java.net package. RAID classes are added by Java SE 6. The java.net package interfaces are listed here. First is the content handler factory, cookie policy, which is added by Java SE 6, cookie store, datagram socket implementation factory, file name map, socket implementation factory, socket options, URL stream handler factory. Like these interfaces are provided in the java.net package. In the sections that follow, we will examine the main networking classes and show several examples that apply to them. Once we understand these core networking classes, we will be able to easily explore the others on our own way. These are the interfaces. Thank you guys. In the today's lecture, we are studied basics of networking and its classes and its interfaces. Also, we have studied the socket paradigm, socket communication, or in networking, socket is nothing but the end point in a network. All we know the sockets of electrical points. Same way in networking, network sockets are used to perform the networking. Thank you. Thank you.